Welcome to my YouTube channel, A Brainery of Civil. Today I am going to solve the fourth assignment of fluid mechanics. First question. The Bernoullis equation is written with usual notation as P by gamma plus V square by 2G plus Z is equal to constant. In this equation, each of the terms represents. So, options: energy in kg meter per kg mass of fluid, Newton meter per kg mass of fluid, Newton meter per Newton weight of fluid, kilowatt per kg mass of fluid. So now, for example, let us take the first term P by gamma. So the units of P are Newton per meter square, it is a pressure, and gamma is equal to Newton per meter cube. Okay, so you will get meter square and meter cube. So this M will go up, that is Newton meter divided by Newton. So generally this gamma is weight density, or it is a specific weight. So it is energy, it represents energy in Newton meter per Newton weight of fluid. Okay, so the option C for question number 1. Next question. The difference between total head line and hydraulic gradient line represents. So generally total energy line or total head line is equal to P by gamma plus V square by 2G plus Z, and hydraulic gradient line, hydraulic grade line is equal to P by gamma plus Z. So this difference, the remaining term is V square by 2G. Okay, so the difference between total energy line and hydraulic gradient line will represent its velocity head. So the answer A for question number 2. Next question, question number 3. Water flows steadily down in a vertical pipe of constant cross section, neglecting friction according to Bernoullis equation is. So for example, I have taken a pipe with a constant diameter. So the flow is in this direction, vertically downward direction. Okay, so vertically downward means H decreases, and pressure P is equal to, we know gamma, P is equal to gamma into H. As H decreases, P also decreases towards the direction of flow, that is with H P decreases, pressure decreases with height. So answer C for question number 3. Next question. In a two-dimensional duct flow, air flows in the bottom half of the duct with uniform velocity and there is no flow in the upper half. The value of the kinetic energy correction factor is. So generally, there is a pipe. He said that there is a flow of air only in the bottom. So that is, this is the velocity profile for the corresponding flow. Okay, so this U is velocity I am taking. According to continuity equation, total area into average velocity over the pipe is equal to half area into U. So you will get V average is equal to U by 2. And coming to kinetic energy correction factor, alpha is equal to integral V cube into dA divided by V average whole cube into A. So here V cube is U cube. So that is V cube, V is corresponding to the velocity and dA is only half area because the flow is only in half top portion, and V average is equal to U by 2 whole cube and A is A itself. So if you will solve this equation, you will get it is 4. So the kinetic energy correction factor is 4 for question number 4. So option C for question number 4. Next. For example, he has given there is a nozzle. The water is applied at an angle of elevation 45 degrees. The nozzle directs a liquid jet at an angle of elevation 45 degrees, the hydraulic gradient line. Obviously, here the hydraulic gradient line is here. Here the hydraulic gradient line is here. So whenever we are joining these 2 points, so the hydraulic gradient line horizontal with level of jet. So HGL will be horizontal with level of jet. Okay, so the answer is question number B for question number 5. And so in the Bernoullis equation, the term rho v square by 2 represents. So you can see in Bernoullis equation there are 3 terms. The first term is P plus rho v square by 2 plus rho g z, that is equal to constant. So here P is equal to static pressure and rho v square by 2 is equal to dynamic pressure. And rho gz is equal to hydrostatic pressure. So the summation of static, dynamic and hydrostatic pressures is a constant value according to Bernoullis theorem. So in this he asked what represents rho v square by 2. So it is a dynamic pressure. Answer B for question number 6. Coming to question number 7. So piezometric head is summation of datum head plus pressure head. Datum head is Z plus pressure head is P by gamma. Okay, so the answer B for question number 7. So, which of the following statements are true with respect to kinetic energy correction factor? He has given some statements. So, which of the following statements are correct? He is asking. So, generally alpha is kinetic energy correction factor. Okay. So, generally in practical problems, all the fluid flows are turbulent in nature. Generally, in practice, all the flows encountered are turbulent in nature. Turbulent in nature. So, for turbulent flow, alpha is almost equal to 1. So, that is we can neglect the value of alpha. Okay. So, option A for question number 8. And so the question number 3 has been repeated. So this is pressure decreases with height. So water flows steadily down vertical pipe constant cross section. So the same question as question number 3. Answer C for question number 9. Next question, question number 10. So he has given some list. So we know this is V square by 2g is velocity head. So for A it is 2. And now coming to P by rho g is equal to pressure head. So P by rho g is equal to pressure head. So that is, it is B4. And C, it is Z, it is datum head. So datum head Z is equal to, it is C3. So 2, 4, 3 are the answers. So option B for question number 10. Coming to question number 11. A horizontal conveyor belt moving at 0.914. So that is velocity of belt is equal to 0.914 meter per second. Receives a sand from a hopper. The sand falls with velocity 1.524 at a rate. So discharge he has given, it is discharge Q is equal to 0.15 meter cube per second. And the density of sand, so rho sand is equal to 1600 kg per meter cube. So the conveyor belt is initially empty but begins to fill with sand. If the friction in this drive system is negligible, find the tension. So first of all we will calculate mass density. So that is mass density is equal to rho Q. So what is rho? It is 1600 and Q is equal to 0.15. So you will get it is 240 kg per second. Okay. So that is 240 this value. And now tension in the cable T is equal to mass density into velocity of belt. So mass density is 240 and velocity of belt is 0.914. So you will get it is 219.36 Newton. Okay, so answer is 219.36 Newton. Clear? Now coming to, so water flows through a 100 mm diameter pipe at discharge Q is equal to, so discharge Q is equal to 0.025 meter cube per second. So by using this, we can able to calculate at section what is the velocity. VA is equal to, and as the diameter of the pipe is same at A as well as at C, we will get VA is equal to VC. So that is VA is equal to VC is equal to Q by A. Q is 0.025. A is equal to pi by 4, 100 by 1000 whole square. So it will be 3.183 meter per second. So this is velocity. And now we will apply the Bernoullis equation at A as well as at C. Okay. So PC by gamma plus VC square by 2G plus Z into C, that is equal to PA by gamma plus VA square by 2G plus Z into A. So he has given the pressure at point A and asked us to calculate the pressure at point C. So the unknown is PC by gamma is equal to 9810 Newton per meter cube plus VC is 3.183. And you can observe that the velocity at C and at A is same. So we can neglect these two terms. Right? And ZC is, we need to calculate this vertical height. Okay. So you can see this triangle. So this is Y. And he has given it is 30, it is 4. It is 4. So you can see sin 30 is equal to Y divided by 4. Y is equal to 4 sin 30, you will get it is 2. So the vertical height is 2 meters. Okay. So that is ZC is equal to 2. Is equal to PA by gamma plus ZA is equal to 0. That is, I have taken datum as at this level. Okay. So by using this, he has given PA as some pressure 225 kilopascal. That is 225 into 1000, 9810. So you will get PC is equal to 205.38 kilopascal. Okay. So the answer for this question is 205.38 kilopascal. And coming to next question, the pump shown in figure discharges water at 80,000 liters per hour. The pressure at A is 150 kPa, whereas the exit pressure in the pipe at B is 500 kPa. The pipe filter causes the internal energy of the water increases by 50 joule per kg and is at exit due to frictional heating, while there is a heat conduction loss from water is 250 joule per second. Determine power. So actually this is a very long answer problem. So I am just giving you the power of the pump. So it is 6.75 horsepower. Okay, so this is the answer. So I am not solving this. It is a very long answer to previous problem. So it will take maybe 30 to 40 minutes. Okay. So you can share my videos to your friends, those who required, and like, subscribe my channel for all the NPTEL updates. Thank you.